Today we're talking about threads in the UI, and I think the best way to talk about threads is to show them graphically. If you look at the three ovals at the bottom of the screen, what the ovals represent is actually processes, and the curved lines within the processes are threads. And a process is basically everything it takes to run a program. The data structures, the JPEGs, the waves, whatever it is that's involved. But the thread is the actual execution part of the program, the stepping through the lines of code, line 1, line 2, line 3, and so on. And if you don't think this is an important concept of modern programming, just go to the taskbar and click on Start Task Manager and go to Processes, and you'll see how many processes there are running right now on your computer, almost all of which you didn't start yourself but were started when you booted up the computer. So a process is sort of like a private universe with data and what have you and threads executing, and the processes generally don't know anything about each other. They just run in their own private universe. But within a program you can write your own threads, and the way I explained this in a previous program on async, on file download async, was you have synchronous processing that is shown in this oval up here, where you have the mainline code in the black running along, and then it, for instance, calls a function, and the blue line represents the function that gets called, and while the function is executing, the main line is totally stopped, and then when the function finishes, the main line starts up again. This is synchronous. In asynchronous processing, you have the main line running along, and then it spawns a thread or possibly another process, and the blue line represents the thread. And as you can see, the blue line is running, but the black line is running at the same time. So you have two things running in parallel. And the mainline thread, which runs whenever you start a program, actually doesn't know anything about the thread that it spawned. It can query what its state is with thread state and isAlive properties, but generally it has no idea what the thread is doing at any given time. They're totally independent things. And a lot of threads are written to run indefinitely. They have a while loop or a for loop, and they're doing something like checking if there's a keyboard press, or checking if a character comes in from a communication line, and then when that happens they do their thing and then go back to sleep listening for those events to occur. And these essentially are threads that run forever, but the mainline thread could stop them by doing a thread abort, which is shown at the arrow at the bottom. And in terms of this program, the way we spawn a thread is a standard thread instantiation, where we have the thread class, a thread name equals new thread, and then as a parameter to the thread we put a function, and the function has the actual code that runs the thread, and then that creates the thread, but it doesn't start it running. What starts it running is you have the thread object name dot start, and that'll start it running and spawn the blue line here. And then the blue line will continue running, and if it's not a thread that runs indefinitely, it'll have a beginning, a middle, and an end like a regular function. And if you generally want to do something in the main thread while the thread is running, because if you didn't, what's the point of having a thread? So you're doing things here, but then when you want to wait for the thread to finish, you can say thread object name dot join, and this will wait on this statement until the thread finishes. So at this point it becomes like a synchronous routine. The main line is waiting for the thread to finish, and then it continues on after the thread is stopped. Well, if we look at the code in ConWin4, everything's the same, and we're creating a button and a list box the same way, and doing a show dialog to show the window application from the console application. But what's different is in the button click, we have a console write that says in button click pre-thread, and then we do the creating the thread that I mentioned before. And in order to do this, we have to reference a namespace called using system.threading at the top of the program, or else it won't know what the thread is. And then we do the thread name.start in order to start the thread, and this returns immediately, and the thread starts running. And sometimes it returns so quickly that I usually use a static routine in the thread class called thread.sleep, which will cause the thread that it's in to sleep for a certain amount of time, a certain number of milliseconds. In the case of this, it'd be 500 milliseconds, which is half a second. But it turned out that it starts enough that we don't have to do that, and I can say my thread.join, and it will wait for the thread because it is already running. And then when the thread finishes running and the join falls through, we do another console write that says in button click post thread. And initially what we want to do is just have a line in the thread that does a console write that says in thread function. So if we go into the DOS box, we see the conwin.cs we were just looking at, and I can highlight this with the mouse and press enter in order to copy it into the clipboard, and then do a CSC space, and then do a right click to put paste from the clipboard onto the command line, and hit enter, and it'll compile the program. And then if I hit right click again and get rid of the .cs, this will execute the program. And as you can see, the window comes up in the way it has the last 3 videos, with the push me button and the list box. And when I press the push me, you'll notice these lines appear in the console window: the in button click pre-thread, in thread function, and button click post thread. If I push this again, see these appear again, and so on every time. So in a way it's just acting like a synchronous function, which is an unrealistic but illustrative thread. But if we do npp for a notebook ++ and then do a right click, we can edit this program and go in and this time remove the comments from the mylistbox.items add that worked in the previous program when we had it directly in the button click event. And we'll comment out the console write. And now if we save this program and go back into the DOS box, we can go up commands by pressing the up arrow and do the compile again, then press the down arrow to do the run. And you'll see, I'll center this program more, that the program comes up again, but when I press the push me, it displays the end button click event and the pre-thread, but there's nothing written in the list box, and the there's no in button click post thread. So basically the program's just totally hung up. If I try to do anything like move it, it'll just say the program's not responding. In other words, it's hung up. And I can't do anything. I can't resize it. I can't do anything. And probably the best solution to this is to go into the console program, the DOS box, and press Control-C for cancel. And that'll terminate what's running in the DOS box, so we're safely out again. And the reason this happens is we have two threads. The main thread, which is the thread that creates the window and all the controls in the window, and the spawn thread. And it turns out the spawn thread doesn't really have rights to the window that got created or the controls within the window, because it doesn't have what's known as the window handle. And there is a way around this. You can get this program to work, but you'll have to do some fairly sophisticated moves that I'll show you in the next video, ConWin4. Well, I hope you enjoyed this program and learned a lot, and don't forget to subscribe.